Previously, we made a discussion over real and virtual objects and real and virtual images. And regarding them, I would like to emphasize a very important point. Important point 1. So, object, it is of two types, real and virtual. Regarding them, their informations, everything we discussed. But the important point is, the real object can be seen by human being because the light is diverging from the object, whereas virtual object can't be seen because the light is not diverging from it. According to the definition of the virtual object, the light converges to that point which is not diverging from it. So otherwise, whenever the light is not diverging from an object, we can't be seeing that. Therefore, it is a very important point. Here it is the real object can be seen, but virtual object can't be seen. Here because the light is not diverging. Here the light is diverging. But we are taking the understanding of real and virtual objects by the geometry. If light converges and light diverges. Then go for another one. Image regarding real and virtual image. Real image and virtual image, these two can be seen by human being. How it is possible? We can easily estimate that the light may diverge from both. Otherwise, we can't be seeing the real and virtual images both. Therefore, here the real image and virtual image both can be seen since the light is diverging from real image and also from virtual image. These 2 points are very important. And let us move on another point. Earlier we made a discussion up to 5th point. Now we start with the 6th one regarding reflection of light by plane mirrors. So 6th one is, let us consider a plane mirror. Object is keeping somewhere in front of the plane mirror. Its corresponding image is formed in it, which is virtual image, of course. Now distance of the image is equal to distance of the object. Mi is equal to m0. Now, if mirror is shifted towards or away from the stationary object by x, suppose the mirror is shifted towards the object by how much? X. Its position say m dash. Definitely the image will also shift by some amount. Let us find that. Say image is shifted to here. Why we are taking the image shifting towards the mirror? Why don't we take away from the mirror? According to the fundamentals, distance of the object is equal to distance of the image. Based on that, from initial position to the final position of the mirror, the separation is reduced. Therefore, here between mirror and the image, separation should also be reduced. For that purpose, to satisfy that rule, the image must be shifted towards the plane mirror. Now here, imagine that object is at rest. So what is the shifting of the image in the plane mirror whenever the plane mirror is shifted by x towards the stationary object? Now, finally, m dash I dash m dash I dash m dash I dash is equal to m dash O. These are the conditions taking from where? The fundamentals. And again, we are going to find the shift of the image. How? See, shift of the image is I dash. I dash is shift of the image. that equal to, we can write I dash equal to m dash I minus m dash I dash. M dash I is equal to x plus mi, x plus mi instead of m dash I minus m dash I dash. Instead of this m dash I dash, we can substitute this m dash o. Now x plus mi minus m dash o is equal to m dash o is equal to mo minus x. Mo minus x. Then simplifying, x plus mi minus mo minus or minus plus x. See here, mi is equal to mo. Mi is equal to mo. These two are gets cancelled. You will get 2x. What do you say? The shift of the image is double that of the shift of the mirror, either towards the stationary object or away from the stationary object. Now, let us move on another point. Suppose the mirror is moving with certain speed towards or away from stationary object. For the same example, let us find the speed of image whenever the mirror is moving with certain speed. Let it be Vm. Then what is the speed of image in the plane mirror? Okay, next. See here, how do you find the speed of the mirror? From here, it is very simple. X is differentiated with respect to time. Then speed of the mirror is equal to d by dt of x. This is equation 1. It is for mirror. And corresponding speed of image. Speed of image is equal to d by dt of 2x is the shifting of image. Therefore, 2x. Here, image is equal to 2 is constant, dx by dt. Yes, dx by dt is giving velocity or speed of the mirror. Vi is equal to double that of speed of mirror. So this is the way how the speed of the image is formed in the plane mirror as the mirror is moving with certain speed. So here, whenever the mirror is shifting by x, the image will shift to double that of shifting of the mirror. Here, if the mirror is moving with certain speed, either towards stationary object or away from stationary object, the speed of the image will become double that of speed of the mirror. A person of height h This is eye position of the person, eye level. Now, what should be the minimum size of the mirror required in order to see the full image of this person in the plane mirror? So, what is the minimum size of the mirror required to see the full image of this person in the mirror? Let us find that minimum size. And before going to derive this equation or finding its value, then the plane mirror should be kept under a condition that the upper edge of the plane mirror should be kept at a level just above the eye position of the observer. That is, the eye position, just above the eye position, the mirror is to be kept. This is plane mirror. Okay. Now, from the head, the light incident on it undergoes reflection and reaching to eye of the observer, and from the foot again incident and after reflection reaches to eye. Now extending them, reflector lights are extended, and this is also extended reflector light. you will get image of the person. Image of the person. This is also H. The basic condition fundamentals, distance of the object, this is object. What is that? X. And distance of the image, same, X. Height of the object, height of the image, both are equal. Now, this is the I position, M dash, this is A, B, A dash, B dash. Now from these two triangles, E, A dash, B dash, E, M dash, similar triangles, E, M dash and E, A dash, B dash are similar triangles. Therefore, we can take the ratio of corresponding sides. Let it be H dash. We are going to find H dash. H dash by H is equal to X by 2X. Therefore, H dash equal to H by 2. This is size of the mirror required. How much? Half of the height of the person. The minimum size. This is the minimum size. For this minimum size, whenever upper edge of the mirror is keeping just above the eye level of the observer, he can able to see the full image. If height of the person is small h and h by 2 size, minimum size of the mirror required, the next go for another one. Based on this, let us move on. Example problem. Size of a dancer, size of the face of a dancer, size of the face of a dancer is given 24 centimeters and 16 centimeters, dimensions given. Height, face height is 24, the horizontal size is ear to ear is how much? 16 centimeters. These are the dimensions of the face of a dancer. In order to see the full image of this face, so what is the minimum size of the mirror required? Condition. Question number 1. For one-eyed dancer, for one-eyed dancer and for two-eyed dancer. Okay, dimensions given how? Height is, means vertical dimension is 24, horizontal dimension is 16. And one more point was mentioned here, eye to eye. Distance is 4 centimeters. Between the two eyes, the gap is 4 centimeters also given. Now, go for the first question. Question number 1. Let us consider a dancer, one-eyed dancer. Other eyes is not working. Now she wants to see the image of face by using a plane mirror. So what should be the minimum size of the mirror required? See, this is a plane mirror. Yeah, the ray is coming from one ear, from here to one eye is there, it is incident on it. She can see from here to here, this part, and from this ear to and reaching to eye of the dancer. Now we are going for a ray diagram, and second one is from here to here. Therefore, the size of the minimum size of the mirror required in this case is, already we made a discussion over the fundamental that what is the minimum size of the mirror required in order to see the full image of a person whose height is given small h. Based on that, dimension size of the mirror required equal to 24 by 2 half, just now we discussed that point, centimeter into 16 centimeter horizontal by 2. It becomes 12 centimeters into 8 centimeters. This is the minimum size of the mirror required for one-eyed dancer. And go for two-eyed dancer. When we go for two-eyed dancer, so what is the minimum size of the mirror required? Now I will explain over here, or otherwise go for another diagram. For two-eyed dancer, this is mirror. Eye to eye distance is mentioned 4 centimeters. This is plane mirror. From this side, from this ear, the light is incidenting on the plane mirror and reaching to the second eye. Extreme position of the second eye means the light is coming here and reaches to here maximum distance. Of course, the light is also falling on this eye and we are taking the maximum extension, that is extreme level. So this eye, the light is start from this ear and incident on the plane mirror reaches to this eye. And similarly, so from this ear, the light incident on it and undergoes reflection reaches to this eye. So here, by the first reflection, here this part from eye to eye, the region was covered. By the second reflection, second ear, and here also from this eye to this eye, repeatedly second time is also covered. Therefore, we should be subtract one time from this equation. I go for the equation, then I will explain there. So size is equal to 24 vertical size. There is no doubt at all. 24 centimeter by 2 into 16 minus 4 by 2 centimeters. So 4 is subtracted by. So here from this ear, the light incident on it and undergoes reflection reaches to this eye, and from this ear undergoes reflection reaches to here. Now, by the first reflection this part covered, by the second reflection again it is covering twice. Therefore, one time that is to be subtracted from it. Therefore, 24 by 2 and 16 minus 4 by 2, which gives us 12 centimeters into 6 centimeters. This is the minimum size of the mirror required in order to see the face of the dancer, which has two eyes. And for one-eyed dancer require 12 centimeters into 8, and for two-eyed dancer 12 into 6 enough. Okay, let us consider a room. Height of the wall is h. A person standing in the room at somewhere, from the front wall he is at a distance of x, and from rear wall he is at a distance y. Now a mirror is hanging over this front wall. Say its height is h dash. Now the question is, the person standing inside a room somewhere, he wants to see the full image of his back wall in the mirror which is suspended over the front wall. This is the question. Let us see. Again, by taking the ray diagrams, incident on it undergoes reflection, reaches to eye of the observer, and from bottom incident on it, on the mirror, and undergoes reflection, and by extending the reflected rays you will get image of this back wall. Yeah, distance of the object is x plus y. X plus y. Actually, this is object. This is image. Okay, this is AB. This is M dash, and this is A dash, B dash. Now, distance of the object equal to distance of the image x plus y. Again, this is O, A dash, B dash, O, M dash. Similar triangles. O, M dash, and O, A dash, B dash are similar triangles. Taking their corresponding sides ratio, h dash by h is equal to x upon x plus y. Now h dash equal to x by 2x plus y into h. H dash equal to 1 by or h by 2 plus y by x. This is the minimum size of the mirror which is to be suspended over the front wall in order to see the full image of back wall when he is standing in the room at somewhere. The dimensions, the distances are given x and y. So this is minimum size required. Suppose if anybody wants to ask a question that if this person is exactly standing at the middle of the room, then what is the minimum size of the mirror required? When he is standing at the middle exactly, then x equal to y. X equal to y. Put here h dash equal to h by 2 plus 1. H dash equal to h by 3. This is minimum size of the mirror required in order to see the full image of back wall. Next, go for right. A boy of height h. He is standing somewhere at a distance L from a plane mirror, and his father is standing behind him, who is at a distance L and having height is 2h. Now the question, there are two questions. Question number 1. Suppose the boy wants to see the full image of his father who is standing behind him. Then what is the minimum size of the mirror required? This is question number 1. And the question number 2. Suppose his father wishes to see the full image of the boy. Then what should be the minimum size of the mirror required? This is question number 2. Question number 2. Yeah, first go for question number 1. See here, boy wants to see the full image of his father. Yeah, father is object. He is object. Yeah, he is observer. Now the light ray incidenting on this plane mirror undergoes reflection, and from the foot incident on the plane mirror undergoes reflection. Now these light rays are extended. So this is image of his father. What is the height? This is image. Height of the object equal to height of the image, 2h. Distance of the object from the plane mirror is 2L. Here also it is. Now this is M dash, A, B, and this is A dash, B dash. Again go for, this is O, A dash, B dash, O, M dash. Similar triangles. Therefore, O, M dash and O, A dash, B dash are similar triangles. Taking the corresponding ratio of their corresponding sides, H dash by 2H is equal to L by 3L. L by total from here to here 3L. You will get H dash equal to 2H by. This is the minimum size of the mirror required to see the full image of his father in the mirror. And the second question is, suppose his father wishes to see the full image of the boy, then what is the size of the minimum size of the mirror required? Let us see ray diagram. Father, boy, distance L here. This is plane mirror. Its distance is also L. Now, the light rays incident on the plane mirror undergoes reflection, and from here incident on it undergoes reflection, right? These two reflected rays are extended. Now here, this is boy's image. This is image, right? From this mirror, this is H dash. This is H already mentioned. This is 2H, of course. Now distance of the object. This is object here. Boy is object. Distance of the object L, and distance of the image is also L. From O, this is A, this is B, A dash, B dash, M dash, O, M dash, and O, A dash, B dash are similar triangles. Again, H dash by H is equal to H dash up to here. What is the distance here? 2L by H. This is a H. What is the distance from here to here? 3L. Therefore, H dash equal to 2H by 3. Same size of the mirror required. Okay, this is one of the variety of questions related to reflection of light by plane mirror.